what I want to do now is transition over to Sean Holmes and Matt Gaffner. Sean is with ONEOK. Sean's the IT lead there. He specializes in building applications in the pipeline and energy infrastructure, and he's currently in charge of a team that's in charge of maintaining the ArcGIS enterprise services and integrations. Matt Gaffner's from DTN. He's got 15 years of using ArcGIS software and a degree in meteorology. He leads a team that provides data interfaces over 100 different weather feeds from services that pipeline customers can consume and start to use inside their organizations. So Sean and Matt are going to be telling us how ONEOK has really come together with DTN and collaborated to enable an interface to make real-time decision making for the field around weather data and proximity to key ONEOK facilities. So this is severe storm warnings and potential lightning strikes, and really kind of contributes to overall safety culture at ONEOK and how we can get this real-time information out to the rest of the organization. So with that, I'll turn it over to Sean and Matt.
Thank you, Jeff. Welcome, everybody. So my name is Sean Holmes, as Jeff has previously mentioned, and we also have Matt Gaffner on here. And we're going to be presenting weather safety here with Pipeline. The issue was that our environmental safety and health coordinators didn't have a good way to notify our employees of when severe weather and lightning was approaching our facilities. What we were finding is that our ES&H coordinators were using multiple sources of information for their weather and lightning needs. What we found was that some were using apps on their phone, others were using things on their computer, and some were just watching TVs. So what they figured was that GIS has all this weather information. Maybe we should approach them to see if they could provide an authoritative source of information for us. GIS has all this weather information ready available in our GIS portal and ready to serve up to the whole company. But the next thing they needed was the ability to send alerts. So they wanted to know when a lightning strike was within a certain amount of distance from our facility. From there, they also needed to have logic of when the alerts were going to be sent. So for instance, they don't want to know when lightning is striking all across the country, but they also don't want to just know, they don't want to be repeated, they don't want to have repeated notifications over and over from the same storm. They want one notification when the storm is approaching and lightning is struck, and then another notification 30 minutes after the last lightning strike has. So when looking at GIS, and as I mentioned before, we already have all the data in a single source. We need to find a way to be able to ingest all this data and send it all out. So we had a couple of options, and for that, I'll pass it to Matt Gaffner.
So when we first started working with Sean and his colleagues at ONEOK, there were two options that we presented that might be applicable to their use case. We have a software as a service application that comes with different alerting features. It's typically, back then, 5 years ago when we started working with Sean, all we had was point-based alerting. We can now alert on polygons, but the alerts were limited to simply National Weather Service watches and warnings, lightning, and then DTN forecaster issued alerts, which are similar to National Weather Service alerts, but they're a little more catered to our specific clients. In regards to the way that we can disseminate alerts, we could send those out via email, SMS, or a mobile application that we provide. The other option was for ONEOK to leverage GeoEvent and simply use data services that we provide on our ArcGIS server. So the GeoEvent option would really give ONEOK the ability to leverage all of the time and effort they've put into mapping all of their assets and facilities, whether they're static or dynamic. They can monitor, mobile assets as well. They can also utilize GeoEvent for things other than lightning and National Weather Service alerts. They could use things like our rainfall estimates to create threshold-based alerting. So for instance, if flooding at a facility might be a concern, they might want to look for an asset that's had more than 6 inches of precipitation in a day, which isn't something that we could do out of the box. In addition, with GeoEvent, there's easy ways to archive data with Big Data Store. so that they could keep those and have a record, something that they can go back to if there's an incident. And the big, another big plus to the GeoEvent server side of things was that it would really minimize the number of business systems, keep everybody using one authoritative source, and then kind of limit the number of screens that people have to utilize. So that's ultimately why ONEOK went with the data services that we provide from our ArcGIS server in combination with GeoEvent.
So as Matt mentioned, GeoEvent was ultimately selected due to our already existing ArcGIS enterprise setup and the customizability and extensibility that we could continue on with. So what I want to do is actually dive into our setup. How did we do this? So to the right, what you'll see is a screen capture of our actual GeoEvent process that's running these alerts. One thing to note here is that GeoEvent is ingesting thousands of records every minute. As we can see with storms that pop up, there are thousands of lightning strikes that can happen within a short time frame. So it needs to be able to take in large amounts of data. And what we can see at the beginning here is that all we've done is just set up to ingest DTN's already existing ArcGIS services. These are just plug and play with no additional configuration needed. All we did was simply add them to our GeoEvent server and they're ready to go. What you'll notice here is that we are monitoring both cloud-to-cloud lightning strikes and cloud-to-ground lightning strikes. The next thing we did is we set up a geofence around our ONEOK locations. So what we did is we built polygons around our plants in certain offices on our whole footprint that needed to be alerted on. From there, what we could do was with every lightning strike that came in through the GeoEvent service, we buffered that by a set distance that our ES&H coordinators wanted. From there, we then looked, did that buffer intersect one of those previously mentioned geofences? If it did, what we did is we took that strike time from that lightning strike and we write it to the geofence. So for instance, if a lightning strike struck at 7:10 p.m., that 7:10 p.m. time is physically written to the geofence itself. From there, what it does is we have another service inside GeoEvent that's monitoring all our geofences looking for an updated strike time. When it sees that new strike time come in, it knows to send an alert. But then this is where it gets a little interesting because we don't want to just keep sending alerts with every single lightning strike. So we need to have a logic to go alert on the first lightning strike, but don't alert on subsequent lightning strikes until it's been 30 minutes since a lightning strike has struck. So what we do there is we've actually set up on our geofence an email flag. So when the new time is written to the geofence, it sends the email and flips the flag saying, I've alerted on this storm. Then subsequent strikes, all that happens is that strike time is written to the polygon over and over and over, resetting a timer on that polygon. So for instance, if the first strike was at 7:10, it sends the alert. And then we have another strike come in at 7:12. All it's doing is writing that 7:12 to the polygon, but it's not re-alerting because it's saying, I've already sent one alert. Then what we do is we have a process that's checking that geofence and comparing it to the current time. So what we do is over time, once a minute, we have it looking at the current time on the server and comparing that to the strike time on the polygon. Once that's reached 30 minutes, it then sends an all clear email and resets that notification flag so it can notify again in the future. So here's what comes out. When we use GeoEvent, we can send emails. And what's nice with these emails is that we can actually write in specific information into the email that is applicable to the end users. What we'll see on the left here is an example email that gets sent when lightning has struck near a facility. What's great about this is that this email has the ability and the right to stop all work. So this is something that ONEOK worked with our environmental safety and health coordinators to make sure that it is written in procedure, that if a lightning email is sent, it has the authority to stop work at any facility. So what we can see here, though, is outside of it just sending an email saying that lightning has been detected and to stop work, what you'll notice is that we can dynamically write in what the geofence name is. For instance, this one is the ONEOK Plaza facility. This makes a more targeted email for our end users that grabs their attention rather than just a generic email that says lightning has been detected, please stop work. If we can call out their facility, they know it's for them and they know there's action to be had. The next thing we do at the end is we can provide a live weather map to our internal GIS portal. So this lets the users go in and assess the situation on a live map and see how bad the storm is, what's going on, and try to get more context as to why an email was sent to them. So looking at our live map here, we can see we can provide a lot more context to our field users and environmental safety and health coordinators. We look at this map, you can see here's our pipeline, and these labels here in the middle are the geofences that we had set up. You can see with some in Mont Bellevue up to the ONEOK Plaza in Tulsa and Hutchinson, but we're also providing other layers, which I'll have Matt Gaffner speak to.
So Sean's map provides a really good example of the full spectrum of weather data services that we provide. We've got everything from data services that are commoditized, like the National Weather Service watches and warnings, radar data that we add value to, and lightning as well. And so with the National Weather Service watches and warnings, we're able to provide those in a low latency method that's reliable, and we've got 24 support for those services, which can be, health and safety related. So, compared to free services that may be out there, getting a winter weather watch 5 minutes late is normally not a big deal and nobody's going to get hurt. But getting a tornado watch, or a tornado warning rather, 5 minutes late could be a big deal to the health and safety of employees. So those are the kind of things that we do to improve commoditized data services like the National Weather Service watches and warnings. But then for things like the radar data, DTN puts in a lot of work to remove clutter, to make it so you don't have to be a meteorologist to know that what you're looking at is precipitation. On top of that, we add a precipitation mask, so you know whether it's rain, sleet, freezing rain, or snow, which at least luckily today we've got an example of all of that on the live map here. And then to go beyond data sets that DTN adds value to, we also have proprietary data sets like lightning, hail, where tornadoes have been, all of which are things that are unique and proprietary to DTN that we create and make available on our ArcGIS server as well. So in working with Sean, we both kind of learned some lessons together, which it was really good to be able to work with a close customer and kind of run into the same issues that we could help each other solve. And so one of the things that was really important was ensuring that whenever Sean was setting up their GeoEvent server, that the cadence for making requests for data was appropriate. The most frequent data, like lightning, updates once a minute. Other data sets only update, every 5 minutes, and even some more that we didn't even talk about only update every 3 to 6 hours. So there's really no need to set the cadence to check for new data every second, maybe not even every minute, when you could do it every 5-10 minutes or even an hour, depending on what data service you're looking at. And that really improves performance by limiting network traffic. And then the other thing that I think Sean and I both experienced when working with GeoEvent is we were trying to use the polygons, like the National Weather Service watches and warnings, as a geofence, because we thought of it as a two-dimensional area. And then once we started using the actual locations that we cared about as the geofences and intersecting them with the weather data, we were able to get what we wanted out of the GeoEvent services that we were setting up.
So the other thing that I think one of the main takeaways from this process is that we also now have a skeleton for other alerting processes. So today, all we went over was our lightning notification service, but we've also applied this to severe weather and floods. As we see regulations continue to pop up over time, such as the new one to check out a facility within 72 hours after a severe weather event, we start to see this become more and more important. So when we set up these other services, such as severe weather, tornado watches, warnings, hurricane watches warnings, flood watch warnings, and those type of items. All we did is we used the same skeleton that we applied from our lightning data set. The inputs are basically the only thing that changed. We may also change the frequency of notification and some other small details, but from then on, it's more just plug and play. The other thing we could do is we could start to integrate it with other systems into our GIS. So for instance, we use it for our employee locations. We have an integration with Verizon Connect, which shows live employee data from their vehicles, so that if a weather event is approaching, we can see who the nearest employee is who's qualified to go inspect a location. The last use we have here is for our pipeline control. This has been great for them to get an alert and be able to look into something real time from the control center itself. With that, they have a one-stop authoritative place where they can go see our ONEOK assets, live weather data, employee locations, and other information that they need to know.